Hello and welcome to this screencast on matrix multiplication. So what I'm going to do is go straight ahead and just define two 2 by 2 matrices that I want to multiply together. Okay, so here I've got the matrix A, B, C, D, which is a 2 by 2 matrix, and I want to multiply it by the matrix E, F, G, and H. Now matrix multiplication is different to any form of multiplication you've seen before, so I'm going to have to go through this quite slowly with an example. Now the first thing we need to check is that the number of columns in the left matrix, this matrix here, A, B, C, D, is the same as the number of rows in the right-hand matrix. So the number of columns in the left matrix has got to be equal to the number of rows in the right-hand matrix. Okay, you'll see why that is in a minute. So the way I check for this is underneath the matrices, I write out their dimensions. So remember the dimensions are number of rows by number of columns. So here I've got 2 by 2. And on the right I have a 2 by 2. And what I do is I just check, but the inside numbers are the same. So if these two numbers are the same, we can multiply the matrices together. Furthermore, the outer two numbers give us the dimensions of the resulting matrix. So I know I'll end up with a 2 by 2 matrix. Okay, right, so what we do in order to multiply these two matrices together is we go across the rows on the left matrix and down the columns on the right matrix. Okay, so first row is A and B on the left matrix, and first column is E and G on the right matrix. And what we do is we multiply the corresponding elements along the rows and columns. So here I've got the matrix A, which is the first row on the left matrix, and that's multiplied by E, which is the first element on the first column of the right matrix. And to that we add the second element along the first row of the left matrix to the second element of the first column of the right matrix. So A times E plus B times G. Okay, and that's the element in the first row, first column of the resulting matrix. Okay, now what we do is on the right matrix, we move across to the second column. Okay, so now we're on the second column. We're still on the first row of the left matrix, but now we move to the second column of the right matrix. And we do the same thing. So the first element is still A, but this time the first element on the second row of the right-hand matrix is now F. Okay, so that's A times F plus, and the second element along the first row is still B, and that's multiplied by H. Okay, so all we've done here is we moved across to the second column and done exactly the same thing. Okay, and finally what we're going to do now, just change the colour, so I've got purple here, is we go down a row. Okay, so now we're on the second row and we go back to the first column. So we're looking at this element here. Okay, so second row and first column. So we have C on the left matrix, and we have that multiplied by E on the right matrix. And that's plus, moving across, we're now on D. So D on the left matrix, and moving down the first column of the right matrix, we're now on G. Okay, finally, second row, second column. So we're on the second row of the left matrix, so we're still on this purple row here, but now we move to the second column, so now we're in the green column. So we have C, did it in the wrong colour, might as well be consistent. Okay, so back to purple, we have C multiplied by F, and that's plus D multiplied by H. Okay, and that's matrix multiplication of two 2 by 2 matrices. Okay, I understand, but I have used algebraic variables here. It is a little bit easier when we start dealing with numbers. Okay, so that's what I'm going to do now. I'm going to just show you an example. So I'm going to do two 2 by 2. Okay, so 5, 6, 7, 8. Okay, so the first thing I do, I check whether the matrix multiplication can actually be done. And as we see here, 2 inside numbers are 2, so therefore it can. Okay, so what I'm going to do now is go across the first row of the left matrix and down the first column of the right matrix. So here I'll have 1 times 5 plus 2 times 7. Okay, that bit gets a bit takes a bit getting used to, but after a while you'll find it okay. Okay, so that's the first column done. Move to the second column. I'll have 1 times 6 plus 2 times 8. Okay, now moving down to the second row on the left matrix, I have 3 times 5 plus 4 times 7. And finally, second row, second column, I have 3 times 6 plus 4 times 8. Okay, so if I just evaluate some of those products, so I'll have 5 plus 14, I'll have 6 plus 16, I'll have 15 plus 28, and I'll have 18 plus 32. Okay, and let's evaluate those sums. So 5 plus 14 is 19, 6 plus 16 is 22, 15 plus 28 is 43, I think, and 18 plus 32 is 50. Okay, so that's the multiplication of those two 2x2 matrices. Okay, well, I'm not going to stop there. I'm going to have a look at a couple of other examples just to show you it does work with different dimensions. So next I'm going to look at is a 3x2, sorry, a 2x3. So just going to make up some numbers on top of my head. 3, 2, 4, make it easy 1. Okay, so here I'm going to multiply these two matrices together, and I've chosen these two just to show you the fact that we can multiply matrices of different dimensions. So this is a 2x3 matrix, and this is a 3x2 matrix. Okay, so this has 2 rows, 3 columns. This one has 3 columns and just 2 rows. So again, looking at the inside number, they're both 3, so we can do this. Okay, the outside number are both 2s, so I know I'm going to end up with a 2x2 matrix, and I'll show you that now. So the method is exactly the same. We go across the first row and down the first column, but just this time there are 3 elements instead of 2. So 1 times 0 is going to be 0, so I'm going to do the multiplication in one step here. 2 times 3 is 6, and 3 times 4 is 12. Okay, so that's first row, first column done. Moving along to the first row, second column, I have 1 times minus 1, which is minus 1, 2 times 2, which is 4, 4, and 3 times 1, which is 3. Okay, that's the first row done. Now move to the second row and first column. So I've got 0 times 0, which is 0, minus 1 times 3, which is minus 3, and 2 times 4, which is 8. And finally, second row, second column, I have 0 times minus 1, which is 0, minus 1 times 2, which is minus 2, and 2 times 1, which is 2. Okay, so if we just clear up, tidy that up, 6 plus 12 is 18, minus 1 plus 4 is 3, plus 3 is 6, minus 3 plus 8 is 5, and minus 2 plus 2 is 0. So in this case, we started off with a 2x3 multiplied by a 3x2, and we end up with a 2x2. So this shows that the two matrices don't have to be of the same dimensions. Okay, and lastly, what I'm going to do is show you what happens if you try and multiply two matrices where the number of rows in the first one does not equal the number of columns. Sorry, the number of columns in the first one does not equal the number of rows in the second. Okay, so I'm going to try and mix these up a bit. Okay, so here we have a 2x2 and a 3x2. Now, straight away I can see I can't do that because this 2 here is not equal to 3. Okay, so what happens if I do try and do it? Okay, so first row, first column, I'll have 1 times 0 and 2 times 3 and Well, I've run out of elements on the left matrix, but I still got this 4 element down here. So, in other words, we can't do it. It's what we say is undefined. So this matrix multiplication is undefined. It can't be done. Okay, and that's matrix multiplication.